In this video, we're going to learn about velocity against time graphs. So these are very similar to displacement versus time graphs, except that velocity is on the y-axis rather than displacement. They look like the graph shown here. So to explore this, we're going to use the PhET simulation that we looked at in the displacement versus time graph video. So let's start with a person who's just standing still. So here we have a graph of what their displacement and velocity looks like over time. Then suddenly we get our person to move to position 2. So if we have a look here, their velocity has taken a sudden spike upwards. But then, because they're still, the velocity has returned to 0. But note, even though their position is still there at 2, their velocity is at 0. So if a person is moving, then they will have a velocity that is non-zero, but as soon as they're stationary or stop moving, then their velocity is 0 again. So in this example, we're going to have our person start at position -8, and then we have them move, after pausing for a minute, they move at a constant velocity of 1 meter per second. So they're just slowly traveling 1 meter per second, and you'll notice their displacement is constantly changing. It's a straight line, but their velocity is still flat. It's just constantly 1 meter a second throughout the whole motion. So that is represented using this graph here. So in this video here, we have our person once again start at position -8, but this time, rather than moving slowly at 1 meter per second, I'm going to go really fast, 4 meters per second. Then they get to the end destination and stop. Now if we have a look and see what this looks like on the graph, so there is the constant flat line when they were still at the start, then they start moving, so their velocity goes up to 4 meters per second, and then they constantly move at 4 meters per second before finally they stop again and it goes back down to 0. So that's represented using this red graph that you see here. So the way that different speeds or different velocities are represented on these red velocity versus time graphs is the height of the line. So if you have a line that's only just above 0, so maybe at a value of 1, that's flat like that, that means you have a slow velocity. But if you have a line which is much higher up, like the second example where it was 4 meters per second, then that's indicating you have a much higher velocity. So in both cases the same distance was covered, but the difference was how quickly that distance was covered. So the way that we can actually work out how much distance or displacement has been covered from a velocity time graph is to look at the area underneath the curve. So along our x-axis here we have the amount of time that has gone past in seconds, and on our y-axis we have the velocity in meters per second. Now you might remember the way that we calculate a distance is we take the velocity and we multiply it by the time. So let's just consider this section of the motion in this time here. So from time approximately 5 until time 9. So we can see that that's a 4-second period in there. And during that time, the velocity is 4 meters per second. So to figure out the total displacement in that time, I can just do the displacement equals the velocity times the time. 4 meters per second times 4 seconds equals 16 meters. So that's a way that I can work out the total displacement or the change in position during that time. But it so happens that is completely equivalent to figuring out the area between my line and the x-axis. So if I was to find this shaded area in here, that area under the curve would give me the total displacement. So this is something very important for us to remember. For a velocity versus time graph, the displacement is equal to the area between the curve and the x-axis. So next I wanted to have a look at what happens if a person goes backwards. What does that look like on a displacement or a velocity versus time graph? So here I've got my person and they're running backwards and forwards. So they run up towards the house and then they're going to turn around and go back the other way. Then they're going to turn around and go back towards the house. And so let's have a look and see what the graph looks like in this case. So first of all we have our upwards slope and our displacement versus time graph and the downward slope when they're going backwards, but I want to focus on the velocity versus time graph. So when the person is moving forwards, we have our velocity versus time graph is a flat line but it's been moved upwards. So when we have a positive velocity, that's indicating we're moving forwards. But we also have cases where the person is going backwards. And in these cases, we can see that the line, rather than going up, it's gone down. So if we have a negative line, a line that goes underneath the graph, then that indicates a negative velocity. So the last thing I wanted to have a look at was what happens in cases where we don't have constant velocity, but instead we have acceleration, a person gradually getting faster. So let's have a look. So here I've got a person and they're moving very slowly, but then they're getting faster and faster and faster and faster and faster. So you can see the person moving across the screen here. Now, if we have a look at the red line, this shows us what this motion looks like on a velocity versus time graph. So originally the velocity starts at 0, very, very low. Then, over time, you get faster, and so you've got this line that gradually keeps increasing. It's got a constant slope. That there is what we call an acceleration, when something changes velocity. And you can find an object's acceleration by looking at the slope. By looking at the slope of the red line, you can calculate the acceleration. So let's just do one final recap now. So in a velocity versus time graph, if there is a flat line, then an object is traveling at a constant speed. Now if that flat line is at 0, that means that the constant speed that the object is traveling at is 0. So it's not moving at all. If an object is moving forwards, then the flat line will be up, like above the x-axis, or if the object is moving backwards, it has a negative velocity, then the flat line will be beneath the x-axis. When an object is changing velocity, we say the object is accelerating. And in a velocity versus time graph, the acceleration can be calculated by the slope. To determine the total displacement, or the change in position of an object, what we do is we look at the area between the curve and the x-axis. And that should be everything that you need to know about velocity versus time graphs. Now it's just time for you to practice.